All right, welcome back to another video where I study for the JNICE-SP. So today it's time for a new topic. It's going to be IBGP and EBGP. So the documentation I thought was going to be useful to learn this topic is all about peering. So it might be different aspects of IBGP and EBGP here that's not directly related to peering. That might be important to the exam, but we're going to take lots of Wireshark captures and really take a deep look into the packet. So if anything jumps out to me, I can always do what I did in the last video where I Googled the collision failed message, and then I'll learn a whole lot more. From the JNICE-IP, there's of course lots of important aspects of how traffic moves through a autonomous system, and if it's inside of a autonomous system, you'll have non-transitive attributes. But if it's moving between autonomous systems, you'll have transitive attributes. So that's for sure, those kinds of things are going to be on the exam. So I'm hoping I'm going to bump into kind of the difference between transitive and non-transitive BGP messages in this. But if I don't, it looks like the next topic I'm going to be looking into is IPv4 and IPv6. So I might need to seek that out specifically and kind of get myself a little bit more up to speed with that. It's been a while since I took the IP. So, all right, but let's start with this lab. So understanding external BGP peering sessions. To establish point-to-point connections between peer autonomous systems, ASs, you configure a BGP session on each interface of a point-to-point link. Generally, such sessions are made at network exit points with neighboring hosts outside the AS. So this is kind of an important thing because since TCP is what BGP rides on, is a TCP session, yeah, you can have in this AS, you know, this router being the closest to whatever's on this side, peering with this router being the closest to whatever's on that side, and use that to to have an EBGP connection between these two autonomous systems. But generally, you're not going to do that. You're going to use the two routers that are closest together, and that's, of course, you don't want latency in your BGP traffic. The other thing is you're going to have that control traffic flooding these other links, which kind of doesn't make any sense, and going redistributing in the RIP and stuff. So yeah, generally, unless there's really good reason to not to do so, just go with what you would intuitively think to do. All right, so figure 1 shows an example of a BGP peering session. In figure 1, router A is a gateway router for autonomous system 3, and router B is a gateway router for autonomous system 10. For traffic internal to either AS, an interior gateway protocol IP is used, OSPF for instance. To route traffic between ASs, a BGP session is used. So here we can see OSPF is using an autonomous system 3, but autonomous system 10 is using RIP, and then any traffic that would go in between is going to be redistributed from RIP to BGP out through, or OSPF to BGP out through, and then redistributed back into RIP or OSPF. And this might be a really good kind of opportunity to learn more about the difference between exporting and importing, because, you know, just intuitively, common sense, you would think, oh, well, I'm receiving a route from BGP, so I'm going to export that from E and import that into RIP. But as we saw in the last, you know, you actually might be importing it from BGP, but exporting it into RIP, because even though you're placing it into RIP, you're telling your, you know, other routers that you have this, and you're using RIP to do that. So you're exporting it out to the other routers, kind of like if you were trading between the US and China, you know, creating whatever China buys from the US, like steel or I don't even know. So even though you're creating that steel and you might think, oh, I'm importing steel because I'm creating steel. Well, no, that's not how the language works. You're exporting it. Yes, you're creating more steel, you're putting more resources into the steel, but you're sending it out to China, so you are exporting. You arrange BGP routing devices into groups of peers. Different peer groups can have different group types, different group types, AS numbers, and route reflector cluster identifiers. To define a BGP group that recognizes only the specified BGP systems as peers, statically configure all the systems peers by including one or more neighbor statements. The peer neighbor's address can be either an IPv6 or IPv4 address. As the number of external BGP, EBGP groups increases, the ability to support a large number of BGP sessions might become a scaling issue. The preferred way to configure a large number of BGP neighbors is to configure a few groups consisting of multiple neighbors per group. Supporting fewer EBGP groups generally scales better than supporting a large number of EBGP groups. This becomes more evident in the case of hundreds of EBGP groups when compared with a few EBGP groups with multiple peers in each group. Okay, so let me kind of put that into, let me kind of unpack that language here. So if I were to go to edit protocols BGP, you can see I've got the option to, I can do set group right here, define a peer group, or I can just straight up set a peer AS, or within the group set up a bunch of different peers. But the preferred way to configure a large number of BGP is to configure only a few groups and then have multiple neighbors in each group. So you wouldn't have a group for each of your EBGP connections. You'd have one group that would be named EBGP, and then you'd have all of your connections within that group. And you do that because having a fewer number of EBGP groups scales better than having an EBGP group for every connection or just a large number. So once you start getting hundreds of EBGP groups, then you might have some performance issues. If you've got only a few neighborships within each of those groups, yeah, just collapse them down and just make a handful north, south, east, west, or just something as simple as that, and then add descriptions to your neighbor statements. You can add descriptions, so there's no need to use a BGP group as a description of why you're connecting to other autonomous systems using EBGP. You can use that in its own description capability that the OS has, Junos OS. After the BGP peers are established, non-BGP routes are not automatically advertised by the BGP peers. At each BGP-enabled device, policy configuration is required to export the local static or IGP learned routes into the BGP RIB, routing information base, and then advertise them as BGP routes to the other peers. BGP's advertisement policy, by default, does not advertise any non-BGP routes, such as local routes, to peers. And we saw that in an earlier video where I couldn't figure out why it wasn't allowing a source address. Well, that's because those local addresses aren't automatically advertised into BGP. You have to do that through its own policy. All right, so example, configuring external BGP point-to-point peer sessions. Requirements: if the default BGP policy is not adequate for your network, configure routing policies to filter incoming BGP routes and advertise BGP routes. Overview: Figure 2 shows a network with BGP peer sessions in the sample network. Okay. Called external peers. I mean, maybe they'll just give the full yeah, it looks like they're just giving the full, actually no, they're just saying copy into a text file. So you're not getting the full configuration of what you need to put into every router in this. I notice sometimes sometimes they do give you that for every single, but I think once it starts getting bigger like this, they just give you an overview that tells you the IP addressing scheme, and then they give you the configuration for one of your devices, and then you're on your own to configure it for the other ones, which is totally fine. I mean, it saves them a lot of space, and then it's good practice too, just to figure out, you know, as I said in previous videos, if you're just blindly typing out or copying and pasting what you see, you're not going to learn as much. But you can see I've got my topology all set up. So all I need to do is go ahead and do that, set up the configuration, and I'm going to do it the way you do it more if you were on the job, and just use a notepad first before I actually go to the command line. And then once I've got that all ready to go, paste it in. So it looks like this is going to be to router A, B, C, D. So I know that this is for router E. So I'll just start off with this. And of course, my IP addressing or my interface scheming is going to be different. I just went from top to bottom and I did 0, 1, 2, 3 on E. And then for all of these, I have interface GE000. So that makes it nice and easy on me. All right. Set interfaces GE000.0 description 2A. And now I think I'll just go ahead and copy this. Yeah. So, oops, for some reason it's not letting me highlight multiple lines, but that's okay. It looks like I need 1, 2, 3, 4, 5, 6, 7, 8 of these. And I'm going to be incrementing it like this. The 4 connections, and then every other one is going to be a description. And from what I understand, you'll be given a notepad tool. I think it's Notepad++. It might just be regular old Notepad. You know, if it is, that's really going to make things difficult. But you will be given some sort of editor. Hopefully it'd be really nice if it were like a Linux tool like but hopefully it's going to be Notepad++. I have a feeling it might be Notepad. That's something I'm actually curious enough to look up right now. JNICE-SP, oops. JNICE-SP editor software available during tests. So here we go. This person had an experience. Let's read about their experience and hopefully, aha, perfect. So the laptop comes with Notepad++. So there we go. That is really reassuring. Okay, so according to this guy's experience, of course, could be different. They could forget to, but one thing I could do is say like to the proctor before the exam starts, like I can look over my tools, Notepad++ is gone. I can say, hey, proctor, I was under the impression I get Notepad++, where is it? And either they'll install it for me or they'll give me some explanation that I can file a formal complaint with Juniper on, because like not having a tool like that you're going to have, it's just not fair. Like I would think that'd be worth filing like a formal complaint with the testing administrators, because I mean, what are you testing someone on? Are you testing them on a skill that they're going to use, or are you just testing them for the sake of, you know, like is your test relevant? Is it something that people would take? Because you know, and then if they respond to the complaint saying, oh, it's not a valid complaint, you know, then watchers of this channel have the heads up that you know, is this an exam that's even worth taking? And I really think this exam is worth taking. I think it's worth studying for. So I think they're going to be providing me with tools that are going to be helpful, like Notepad++. And of course, if I show up and it's not there, I will just flag down the proctor and say, where's my Notepad++? And if they say, you don't get Notepad++, you don't get anything at all, then I think I'm more than justified in sending an email to the support center for Juniper, maybe getting some sort of perk, like a free retake or something. But that's kind of, I think it's important to be prepared for a situation like that. But of course, more important, since that situation is so unlikely, is to be prepared for actually knowing the content of the exam and being able to pass it, which is what I'm doing now. That's kind of where anxiety can run amok, is when you're spending so much of your time thinking about these outside rare scenarios and how you'll react to them, that it turns out you spent all day doing that and you didn't study for the thing that's most likely going to happen. You're being asked about specifics of IBGP and EBGP connections. So, all right, so edit, set protocols, Bgp Group. So here's an example of how we've only got one group, but we've got 4 peers within the group. So of course you could make a group that says router A, router B, router C, but that is definitely going to be less less ideal than just having one group with all your connections in it. Even if you have a customer, a bank, grocery store, you might be tempted to say, here's a group for the bank, here's a group for the grocery store, but no, like have maybe a regional group if you have, you know, hundreds of external peering sessions, but really you want to keep those BGP groups as general as possible, and then add the more specific information inside of them. All right, it's 1, 2, 3, 4, 5, 6. Perfect. Type external. Peer AS22. Neighbor 10.10.10.2. And I think I'm going to go the extra mile just to reinforce what I've learned. And I'm going to prevent those multiple race condition 3-way handshakes that we saw on the Wireshark Capture. And I'm going to do that by specifying which router is going to initiate the BGP connection. And that prevents both routers from racing to initiate that BGP connection, and then one router saying, oh no, I can see you're sending a BGP open message to me, but your source address is the same as the destination address I used to try to send that same message I'm receiving right now. Well, let's look at your ID. Oh, well, your ID is bigger than mine. You have a higher ID. So I'm just going to send some fin packets, let you know, no, it's cool. You got it. You got the higher ID. Here you go. Or you say, oh, yours is lower than me. I have a higher ID. You know, I'm just going to keep going and connect this. And then this one, of course, goes, oh, well, I've got the lower one. It's cool. Here's your fin packets. Goodbye. So just by looking at the Wireshark, we were able to figure out how that process works, which is really useful. And we were also, just by Googling that issue, able to figure out how to resolve that process, which is something I will demo once I put this configuration on the device. But for now, I'm just getting it ready in advance. And it looks like this is all we're going to need for this configuration. This should be pretty quick and easy. So I'm going to space this out so that it's not too much to paste in at once. Another thing I can do for later video is set up a management network and then paste everything in through management. I have a feeling things would paste in a lot cleaner than two, because one thing a lot of networking students have a question with in the lab is, oh, why can't I paste in all this config? Like, it's not going in. Like, is this seriously how these devices work? Because if the internet is like this, where I can't even paste in a small text file without it all messing up, like, is that the kind of internet I'm learning to serve? Like, that doesn't make sense. But what they don't realize is you're using a special cable. You're using that console connection, which is just a serial connection that only sends a few bits at a time. So when you send it in band and using that console cable is out of band, then you're going to send it over Ethernet. And that's when you can send videos, you can watch Netflix, you can do all that stuff if you have traffic that's in band. Well, in band, out of band is just basically vernacular about how you are interacting with a device, either in band with its regular traffic or out of band, not affecting its regular traffic flow with all the Netflix and all that kind of stuff. But that's one thing that often kind of confuses people new to networking is, why am I not able to send a lot of information rapidly to the device? Well, you've got to look at your management method. Are you in band or out of band? Because if you're out of band, you're going to be using serial or some really slow, low bandwidth way of interacting with the device, but you're going to be out of band, so you're not going to disrupt the regular traffic flow. If you're in band, you're going to be kind of disrupting that traffic flow a little bit, but usually links are not utilized to a level where you're going to be disrupting of it. And then even then, you probably have some sort of QoS policy set up for your management network where you either can't, where you can't really disrupt the flow too badly. Although there are kind of pros and cons about how you set that up. One option you have, of course, is to just say, I don't want any of my management traffic to affect the regular traffic going through this device. So I'm going to have my QoS policy for my management traffic prioritize my management connection the least, so that I know whenever I'm in the box, I'm doing no harm. Any traffic that is essential is going to just kill my management session. I'll just try recreating it again later and I'll be fine. Of course, there's the other side of the coin. If I need to get into the device, I need to get into the device. There's probably a huge problem that I can fix by being in the device and just toggling some sort of knob, or even I just need the stats to figure out what's happening later. Like, I just need to know what is happening on this device and I need it now. Well, then you can, of course, set up your QoS policy so that management traffic is the highest prioritized traffic. And no matter what's happening with congestion on the device, if you form a management session, it's going to prioritize all of your management traffic. So there's just kind of two different ways to think about how you manage your network in general. Do you want to have the capacity to be more hands-on, but potentially disrupt some of the services you're delivering? Or do you want to kind of not have as much hands-on capacity as you potentially could have, but not be able to accidentally disrupt the services anyway? I would kind of, my personal opinion, I kind of would prefer the more like hands-off approach. Like, if a device is really like kind of messing up, I don't even know what you could really do on the command line too much. Like, yeah, so it's like command line tricks, you know, going in remote management. If things go really wrong, they all kind of break down anyway. So that's kind of where I fall on the side of the coin as to whether you want your ability to provide remote management just set in stone, pristine, this is the most important thing you can have, or if you want the integrity of your traffic, the stream that your customer is getting, if you want that to be the most pristine, perfect. I fall more on the line of the services you're providing being more important than your ability to mitigate some sort of issue or disaster if that were to occur. All right. So let's see here. Okay, so I think it's time to paste these in. Show pipe display set relative. So, and then I'm going to slow down on these. Make sure this gets in there. There we go. And I'm going to show a special command. So here's another reason why the running theme behind this channel is understand the concepts and not the commands, because I don't even know what is beyond here. I don't know what my options are, but I would be willing to bet that one of the options is passive. Aha, perfect, see? And that's because I understand that concept of that race condition and how it's not specified by default which router initiates the BGP session. So they both try to do it at once. And how would you even specify that? I mean, it's just TCP. They're just sending out SYNs. And then whoever responds to the, oh, I got your SYN. Here's a SYN ACK. Oh, you got my SYN? Oh, thanks for the SYN ACK. Here's the ACK. Now we're doing a connection. You know, you can't, before it's already connected, there's no way to tell which one you would prefer initiating and which one you would prefer responding. Well, what you can do is you can disable those SYNs, those open messages from one side. So you only are going to receive those TCP SYNs from one of those BGP routers, and you prevent that race condition entirely. And you do that with this keyword here, command. Do not send open messages to a router. So it's kind of an interesting thing to learn about. And it's a really good example of why concepts are way more important than commands, because I could just memorize the command passive, but passive means something else depending on the protocol I'm using. If I'm using OSPF, passive means to include the subnet that the interface is configured on in your link state advertisements out to other routers, but don't send those link state advertisements over that interface. So it means something completely different depending on the context it's in. So knowing the command is really not important at all. What's really important is to learn the concept. And the reason it's not important at all to know the command is you've got this question mark, and you can see, you know, every word counts in this message, and usually that's plenty. That's all you need to know. Do not send open messages to a peer. I mean, no matter what this command were called, passive, no send, docile, you know, it could be any one of those words, and I would know what it meant because I understood the concept. So yeah, so now I got to think about where I want these to initiate from, and I think I'm going to have them initiate from the other side here, because yeah, no reason in particular. I guess this is one device feeding many. So if this device is going to be sending out open messages, it's going to be sending out 4 open messages. Whereas if I have it be passive and only these devices are sending out open messages, you can see they're each going to just send out 1 open message. And then this device, I've saved the device from having to send more traffic. So I'm kind of using that conservation in mind to choose how I configure this passive command. So I'll be putting it on this one because I want this to be less burdened with control traffic than these, because this has a greater number of peers. This has 4 peers on each of these, but these only have 1 to here. So if these are all responsible for sending the open packet, then each device only sends one. But if this is responsible for sending the open packet, yes, these don't have to send any at all, but this has to send 4. So each router doing, you know, many hands make small work, that sort of concept. Like, I think that's generally a better way to think about things when it comes to networking. And of course, you can have situations where many hands doing little things can lead to big things and overflood your network. I mean, if you're following anything to do with the COVID-19 stuff, you can see how, you know, just the fact that one person can get, you know, 3 or 4 other people sick by coughing or whatever, you know, can make billions of people get sick. Like, yeah, obviously one person doing small things can lead to big things, but yeah, it's just something to think about. This is kind of more of a question about network design, which has its own track when it comes to these tests. This one's more specifically about the nuts and bolts, down and dirty, like plumbing, and not necessarily the room decoration or whatever. But it's always important to have kind of concepts in the same family that you'll be dealing with in mind, and so that you're all kind of working together to deliver one cohesive thing instead of all kind of at odds with what eventually gets done. Or at least you have some sense of like where there is a fence. Like before, there was the question about where do you lean in towards of, do you want management that is always available for you, even though you might be squashing some of the traffic, or do you always want that traffic to be pristine, have #1 priority, even though you might not sometimes be able to get into a router? So just kind of being aware of where people might follow along for that is something that's good to know. And having a strong opinion one way or the other isn't always as useful, in my opinion, as just knowing where those lie and what people might think and where people might lean towards, and really kind of make those big design changes. Because you're going to see, of course, networks that are designed with different kinds of principles in mind. So if you just don't know that, you know, there's another way, or you only think there's one way to do it, you're going to be really surprised if you see the other way and kind of start to question yourself and like question them, especially, and say, oh, you guys are idiots, you made this terrible mistake. But you might not realize, you know, it's a very real question about trade-offs. Which one do you want? Which benefits do you want? And which negatives are you willing to tolerate to get those benefits? You know, those are really situation context dependent decisions. So it might not necessarily be that, you know, your network architect is an idiot. It's that their requirements are different than what you are used to seeing in the real world, and you've only been seeing that one side where it really skews towards these particular decisions. That's really important to know, is to kind of have enough knowledge to know when you don't know. That's always really important, and to defer to experts and really talk to these interesting people. I mean, if you get the chance to talk to a network architect who's been working for 10, 20 years designing networks, like, talk to the guy. Don't say that they made a bad decision. Like, I mean, that's a really good opportunity. All right. So looks like edit route. Oh, there's no S, just edit route option. So, oh, let's see here. Set route. Oh, routing options. Okay, yeah, so there is an S. So this must have come from the documentation, because I'm used to using this command. I use it a lot of the times, every time I need to configure an autonomous system. So I'm surprised I would have entered that in incorrectly. Oh, no, it's just me. All right, so let's do show pipe compare. And you'll notice we've got all passives. So if I start a Wireshark capture on any one of these links, I'll just pick the first one. And then I do the commit when I'm doing the capture, we won't see those TCP SYN messages. So I'll commit right now. And when it starts up, we'll probably see, oh, what kind of traffic will we see? We'll see it when we see it. Yeah, I mean, honestly, we won't even see anything. I mean, we'll see ICMP, we might see an ARP if we do an ICMP, but that's only going to happen if we actually actively ping it. There are gratuitous ARPs, which are just sent out every once in a while to make sure your ARP tables are up to date. So we might see one of those. Often gratuitous ARPs are set when a interface first comes online, just to announce to the world, hey, I'm here, update your ARP tables. Generally, you know, gratuitous ARPs are gratuitous, so some vendors choose not to have them because it's just extra things hogging your bandwidth. Control traffic can really add up and eat up a lot of your bandwidth if you're not, especially as we saw with BFD sending out tiny packets every few milliseconds. All right, so let's just go ahead and verify that it is in fact sending or capturing, I mean. Okay, so I didn't set up the other side of the link with the IPs yet. So of course we're not gonna be able to capture any traffic. If I do a show interfaces terse, it'll show me that it's up. Oh, actually that's good. So it shows me that it's down. Usually it'll show you that it is up even though you haven't configured the other side, but that's only because this is a VM and it doesn't really know if it's up or down. But yeah, it's no surprise I'm not able to capture anything because I didn't even finish configuring the topology yet. All right, so it's going to be way easier on the other side. We're just going to need one of these, and it's always going to be 000. And then likewise, we're just going to need one of these statements. We're not even going to need the passive command because we're going to have the other side be passive. It's only going to be initiated here. We're going to need the peer interface, or sorry, the peer AS, which is going to be 17 for the first 3 routers, and for the next 3, or for the next one. All 4 are going to be peering with 17, but the source autonomous system is going to be 22 for the first 3, and then 79 for the router D. So we see this is going to be .2. So this is it, really nice and easy, stripped down config. And now I can start the Wireshark capture, and we'll see that those TCP SYNs are only being sent from .2 and not .1, which before they were sent from both sides, and then you would have that race condition. All right, so just need to paste this in here. So 2A, and this is going to be router B, configure private. There we go, show pipe compare. All right, maybe double check it once. Okay, so we can see I actually, even here, I pasted it into the wrong router. So these are lessons learned in the lab. This can happen in production. Another good tip and trick you can have in production is only open one at a time. Even though you've got tabs, yeah, if you're just doing show commands, you're just looking around the network, yeah, like having multiple tabs open, you know, do what you need to do. But when it comes to configuring something that's going to potentially affect live traffic, Just take it one device at a time, double check that host name, make sure you're doing what you think you're doing, and if something happens you don't expect, you have a record of everything that happened. So that's really important, and you can see how often that really can trip somebody up. I mean, I just pasted the configuration for router E into router A, and then I tried to configure router A with the configuration meant for, or I tried to configure router B with the configuration meant for router A. So that's something in production that I hope anyone who watches this, which it's really not intended for a audience, it's just intended to help me study, but if anyone happens to find this kind of content interesting and they see that, I hope they can really avoid that kind of mistake in production where they paste the wrong configuration or paste the right configuration into the wrong device and then cause an issue. So this configuration, I can actually roll it back. And then it belongs here. Oops. And it looks like there's, okay, it just didn't, yeah, sometimes it's got problems taking everything from the clipboard, but you can just space it out all nice and there's no problems. All right, so now it's on the correct device, router E, so I'll just commit that. Before I do that, I'll roll this back. Oh, it looks like I already did, so it's good to go. So now I've got the correct configuration that belongs on router A, so that's what goes in here. And before I commit that, I'll have that Wireshark capture going. So here's what I'm about to commit. So it looks like it's already going. So I'll just commit that. And we'll see TCP SYNs pop up, but they'll only be sourced from .2, and we won't see any from .1. Here's this gratuitous ARP because that interface just came online, so it's announcing to the world, here I am, update your ARP tables. So you can see it's going to be sent to destination broadcast address. It's going to say, here's my sender MAC address, which of course is the same as the source address. Here's my sender IP. So that's what ARP is. It's Address Resolution Protocol. It's for mapping MAC addresses to IP addresses. So, and then it maps it learns your sender MAC and your sender IP, and then other devices keep a table of that. So we can actually go in to router E here because we saw that it was sent from there, and we can see when we do, so if I do show ARP, there it is. It's well, let's see here. That's interesting. Okay, well, it doesn't have it. That's interesting. So I wonder if there's an issue. It says that it's still up. No, it's able to do it. Now it has it. So I guess that gratuitous ARP wasn't enough for router E to go ahead and update its table. It needed more than that. And we can see the message it received that it actually, well, I guess we can't see that. Well, maybe there's like a special table for gratuitous ARPs or something. So is there like an all or a detail or something like that? Well, I don't know, but you can see now that I can ping it, I've got that ARP entry, and we'll see that build up for each of those new connections. The other thing I'm kind of surprised by is that there's no BGP or TCP happening. Let's see what happens if I do a ICMP ping. I think I already did one. Yeah, I already did one, and we saw that it didn't go through. So the reason we're not seeing an extra ARP beyond this gratuitous one is because good old reliable GNS issues, it just stopped capturing. So I'm gonna have to stop it and then restart it. And I can of course do a clear ARP if we want to see those ARP packets. So I just clear ARP on interface 000.0. And now we'll see when I ping. And hopefully it's, yep, so now we've got the gratuitous ARP, or no. So we don't have the gratuitous ARP anymore because the interface is already up. But we do have another broadcast ARP. It's not gratuitous, it's just a broadcast ARP, just a regular ARP, but it's got all the same message sent to the same broadcast address. It's just, instead of it being sent out, you know, just because, it's sent out because I tried to ping the other side. So, yep, we can see here's the source MAC address, and this all happens at layer 2. You can see there's not even any IP addressing information here. Yes, there's IP here, but it's because we're mapping where that IP is. We don't actually have the IP. So down here, here's the return, the reply. So in the source, we've got the sender IP target, and of course they're going to flip in the reply. And then we've got the target MAC address, of course, is just, it's just, we don't know what it is. So we don't know what the target MAC address is. But you can see in the reply, we've now learned a target MAC address, and it's going to be the source address that was specified in the ARP packet received by whoever received it, because of course it's going to be broadcast to everyone, and it's going to say, hey, like, I have who has 10.10.10.2, tell 10.10.10.1. Well, gets to somebody who has 10.10.10.3. I don't have it. I'm not going to tell anyone. Discard it, move on with life. Gets to somebody who has 10.10.10.2, and it says, oh, well, here's your sender MAC. Here's the target. So I have 10.10.10.2. So here's my MAC address. So it's going to tell, so this is sent from, you can see this is sent from the router E with 10.10.10.1, but it's sent out to the broadcast. So when a router says, oh, I have 10.10.10.2, it sends this packet here, and it sends it unicast, not broadcast. You can see it's specified a destination. It doesn't just say broadcast. It's unicast to the what was originally the source address, and it says, I have it, and here is the MAC address that you would have used if you wanted to send it to me directly. Now, any subsequent messages, sure enough, you can see, you can use that for me and contact me directly instead of bothering the whole neighborhood. So that's a good deep dive, I think, into how ARP works, ICMP works. I'm gonna get some water. I'll be back in 1 minute or a few seconds. Okay, so coming back, let's see here. So yep, now we're gonna kind of went off on a tangent there explaining how ARP works. I always like to explain that just because I feel like I really understand that really well. And I think a lot of people, even at a pretty high level in networking, kind of don't follow the theme of this channel, learn the concepts and the commands will come, and kind of take the other approach, learn the commands, just kind of memorize the sequence of actions and then move up that way. And I really don't think that's the way to go. So I always kind of like to make it clear that I do understand the underlying concepts, because I think that's kind of refreshing. I think it's really important for people to hear. Of course, I don't like to talk people's ear off. If we're doing a maintenance at 2 a.m. and we just need to enter a command, I'm not going to spend an hour explaining how that command works, but it's definitely, I think, kind of an aspect of networking that is in some areas can be lacking, I think. All right, so let's see here. Okay, so this is going to go on word B. So I've got my source address is going to be .6. My neighbor is going to be .5 now, peering to 17 with my autonomous system being 11. So this looks good. I'll do a Wireshark capture on that. I'm surprised we didn't see the neighborship. I guess I wanted to, before I moved on, see if the BGP came up. Oh, and it looks like it did not. So yeah, I mean, I guess I might as well just troubleshoot this now before moving on, because it's pretty clear that those other ones probably aren't going to work if this one didn't work. So let's investigate this. I wonder if it has to do with that passive command. I mean, if you have passive on both sides, obviously it's not going to work. But you can see very clearly I only have it on router E. Oops, and it looks like I forgot to put it on this one. Oops. Oh, that's interesting. So I put it on there. It went through fine, but it just didn't make. Oh, okay. It's in a second command. So that's interesting that it's just not sending out anything at all. So pure AS22, is that the AS I have configured? Yep, I've got 22. Pure AS17, do I have 17 configured? I do. And they can ping each other. So this is going to .2, this is going to .1. No, okay. So, yep, good troubleshooting there. Fortunately, little typo can cost you a lot of time, but it's good to have that practice and be able to look at those little things. I mean, a lot of times in networking, it comes down to what's the difference between a 1 and a lowercase l. And it's like, oh. So, all right, commit and quit, and then we'll see the BGP TCP SYN traffic being sent, assuming it's still capturing, which I don't think it is. Nope, it's no longer capturing. But I'll just move on to the next one. I'm sure if I do a BGP summary, yep, it's established now. So I'll just move on to the next one, and then we'll see the BGP open messages and the TCP SYNs only being sent from one side, and it's going to be from router B. So I didn't last time switch the neighbor. I kept it at that too, but this looks good to go. So let's paste that in there. Come on. There we go. Oops, and it looks like, oh, okay, this is from before, so I'll just roll back 0, paste the new one in. So, yep, and now I'll get the capture going so we can see that those BGP opens are only going to be sent from B. And it'll be interesting to see what happens with the three-way handshake. I think it'll be only sent from B, only initiated from B, but we'll see. It's like, because it did say in the description that it only applies to, it didn't say that it only applies to, but it specifically called out BGP open messages. And this is more relevant to that initial TCP SYN message, because those BGP messages are only going to come after that TCP handshake. So if it's a command that only affects which side sends the BGP open messages, already you're not preventing that race condition with the three-way handshakes, because those are initiated by TCP SYNs and not BGP opens. So it's kind of an example of how you don't get the whole story from the description, and can you even blame them, because they only got like 7 words to work with max. So so there's our gratuitous ARP for this being up. And there's our initial ARP. So perfect. Okay, now we're talking. Perfect. So I can even stop the capture now. And then we'll go over and take a deep dive into what has happened. So we've got our gratuitous ARP for the interface being up. Then we've got our ARP coming from, so this is going to be asking about .5. So it looks like the device that sent that ARP is going to be router B. Router B sent out that ARP. So who has .5? Tell .6. .5 says, well, I have .5, and it's at my source address right here. And then, of course, it already has the source address of who was asking, because that was sent along with that right here. But, of course, the target MAC address it doesn't have. But now that it says, oh, yeah, I have .5, and you, I know that you gave me your source MAC address when you asked me. So now I have your source address. I have your IP, because you told me to tell the person with this IP, and now I have and of course I've always had my IP and my MAC. So now in this return traffic, you have all of that. And then it looks like this was initiated by router E as well, but it had already been, oh yeah. So it looks like it happened on both sides. Both devices were asking, and both got a response. So these kind of look like they wouldn't be necessary. I wonder if there's like a version of passive for ARPs as well. But either way, it seems to be working. And then here's those SYNs. It looks like we went right to the SYN-SYN-ACK, but you can see a TCP SYN, and we can actually, this looks like it's the only SYN in the whole capture, but you can see it was only sent by .6. We did not get a SYN from .5, and that's because of that passive command on the neighborship configuration under BGP. So here's the SYN-ACK. So we prevented that race condition, and we don't have those 10 to 15 packets that are just completely useless anymore. All right, and then we've got our open message, and we don't have anything being advertised into BGP right now. Nothing's advertised into default. So our update message is going to be completely empty. We don't have any routes being added, any routes being withdrawn. Nothing is advertised into BGP by default. Okay, and then we've got some extra keep alive messages. Looks like we've got some extra acts. I guess I'm not sure what these are all about. Yeah, kind of not sure what those are all about, but the interesting ones are specific to BGP, and if we actually filter out for BGP, are going to be the opens, keep alives, and the updates. Yeah, kind of just curious what all different kinds there are. So open, keep alive, update. So let's see what kind of messages there are total. There's going to be open, keep alive, update, and then also a notification. So this is, I think, yeah, so if there's an error condition, but open sets up and establishes BGP adjacency, keep alive ensures that BGP neighbors are still active, and then update advertises and updates or withdraws routes. All right, moving on to the next one. Router C. So router C is going, oh, and it looks like we've got a wrong description on some of these. So I'm gonna actually go back to router A and router B, and I'm going to make sure that the descriptions are correct. It should say to router E. So show interface descriptions. Yep, and it's just to router A, which of course is not correct. So edit int 000.0, and then delete description, and then set description to E. Oops, and I want a dash, and you don't need to delete it first, it overwrites it, but there are some commands where, like for example, configuring an IP address, it won't overwrite it, it'll just add a second one. So there's nothing wrong with kind of having that as a habit that you do, just kind of because it'll save you and it won't ever destroy you. So those are always really good habits to have, habits that will save you but won't affect you, of course, except for in a little bit of time loss. But if it's a negligible amount of time loss, then, and you can get a benefit from it, then yeah, I think it's a good habit. Oops, so you're gonna edit it and then set the description to E. Perfect. So now those descriptions are nice and squeaky clean. So it looks like I closed Notepad++, so I'm gonna need to open that again and use correct descriptions. The good news is this won't have to change from device to device, so I'm saving myself some extra configuration, however small. It's always good news. This is gonna go to, oh, actually this is gonna be .10. It's gonna be going to .9. And then the autonomous system .22. So really easy, simple changes. And we won't need to do a Wireshark capture on this one, just for, in the interest of time, because the other one was, they're all going to be the same device to device. So just as long as all my BGP connections are established on router E, I think that's where I'll end this video for now. And then the next video will be the verification video. We might even dive a little bit deeper into those BGP messages, maybe take a look at some of the well-known or the optional attributes of BGP and see how the BGP packet changes based on whether they're added or not. And then we can also add routes, withdrawal routes, and see how those Wireshark captures change. But for now, I've just got one more router to configure. And then of course I've got the kind of verification steps that I'm just going to do that aren't in the documentation. But after that, that will be it. All right, so as long as all 4 of those BGP sessions are up on router E, can definitely stop the video here. Let's take a look. Show Bgp Summary. So, oh, we got one that is down. So gonna need to figure that out before moving on. Oh, it looks like I used 10.21.7.1. I'm not sure where that came from. Oh, okay. So I think what happened is I did 10.10.7 on router D, and it's meant to be 21, not 10, for the second octet in the subnet. So show interfaces, oops. Show interse pipe match G dash. Yep, sure enough, it's 10.10, so I'm gonna need to go in here, private. Delete family inet, set family inet address 10.21.7.2/30. And now, of course, I've got to change my neighbor, BGP external group, external peers, show pipe display set relative. And now, yep, sure enough, 10.10. So I'm going to delete neighbor, and then hopefully my HUD for, there we go, delete the HUD, the Zoom hub popped up and I couldn't see what I was typing, but luckily that went away. So now all I gotta do is set it. And there should be just 2 changes. Perfect. And now this should go into active. And that could have been a really interesting thing to look at in Wireshark too, because it's since it's initiating from the other side, I would be willing to bet that you actually wouldn't see any traffic. So I'm going to go ahead and put it back into the state it was before just by rolling it back. Roll back 1, commit. So we're going to see this go back into active state. And then I'm going to stop the capture that we had on before. Looks like they're all stopped already. And then start it on the link to D. Oh, and it's taking a bit longer. There we go. But now I'm going, oh, this is interesting as well because we've got, oh, we've got a FINAC. I guess I wasn't expecting to see that FINAC. So is that, oh yeah. So it is definitely a BGP message, you can see. So maybe it wasn't done closing that, or I guess I'm curious why the FINAC is coming from .1 when we had that passive command set up on there. But it's a fin, not a sin, so it clearly must be different than what I'm expecting. Kind, no operation. Let's see what this is. But these are very clearly BGP messages because you can see the source port is 179. And you can even see, yeah, this actually did initiate from .2. So even though they're TCP messages, and you know, I would have thought you'd only see it originating from .1 or sorry, from .2, but the source is .1. Well, this is in reference to a connection that had already been established, because you can see its source port is 179, its destination port is ephemeral. So whenever a TCP connection is established, it's established from an ephemeral source port into the port of the receiving router, whose service that establishing port is interested in using, which in this case, port 179 is BGP. So we can see it's in the process of trying to, you know, kind of like, what the heck, is this still happening? Are we still doing this? And it's sending out a FINAC. And it looks like what it's trying to do is say like, hey, like, you know, this is done. Let's stop this. Like, here's a FINAC. Like, let's stop this connection. I don't need this connection anymore. But clearly, since this IP is no longer configured, it's not able to get that response back. So the router's just left hanging, being like, hey, I thought we were done talking. Can you tell me we're done talking? Like, here you go. But it's not getting anything back, so it's just going to keep sending those out. It might be interesting to see if there's some kind of like hold down timer coming into effect where it's no longer going to be sending those messages or something. You can see it's registered as a flap. Let's take a look at show BGP neighbor 10.21.7.2. So last event stop. I mean, that'll be interesting to look at, is BGP events, error cease. So this looks very familiar to what we get in the Wireshark Capture. Last flap event, RC notify. Let's see if there's any details on that. Oops. Let's see what kind of options we get. Instance. So it looks like this is the most detailed output we can get, but thankfully there's plenty of details. I'm kind of curious what kinds of BGP events there are. It looks like this is a stop event. So let's type in BGP events. So hopefully we can get like the, or let's narrow it down and say BGP stop event, because I'm sure we'll get more general information. Here we go. So perfect, right from the source, the RFC. So stop event. Okay. In response to the stop event initiated by either system or operator, the local system sends notification message with error code cease and changes its state to idle. So we're probably going to see it change to idle. But this is in response, and that's the problem, is we're not getting a response because that IP address has been changed. And you can see it's not changing to idle too. So that's something that only happens in response to those messages. So this is the only time, it looks like stop event only shows up 3 times. We get more for, here's the different kinds of events. We've got a stop event, a start event, so I don't really see any general explanation about events. Here we go. Perfect. So you can see, you know, just how wonderful RFCs can be. Like, there's really no reason to shy away from diving into a RFC, because you can see all the states: idle, connect, active, open send, open confirm, established. How can you get any clearer than that? It's all just listed right there. And then the same thing with the events. So we've got BGP start, BGP stop, BGP transport connection open, BGP transport connection closed, BGP transport connection open failed, BGP transport fatal error, reconnect retry, timer expired, hold down timer expired, keep alive timer expired, receive open message, receive keep alive message, receive update messages, receive notification messages. So it's all really clearly listed right there. And not only that, these are all very Googleable terms that you can use to find more information if the information here is not enough. And we can even see what happens based on the kind of message. So if it's in an idle state, let's see here, or connect state. Yeah, it looks like it'll tell you the kind of the actions that will occur and the messages that will be sent. If it's in an idle state, it won't send any, but it will initialize resources, start connect retry timer, initiate a transport connection, any other states besides, yeah. And then in connect state, I guess I'm kind of confused why there's these numbers here. Oh, maybe it's, so one is the BGP start. I guess this is kind of an example of how sometimes RFCs can, your fears are a little bit justified that an RFC is just going to be something only for the top level experts. And, at this point, you might want to seek out an educational material instead of just a technical manual meant for the highest level experts. So, but you can see very clearly there's this describes the state transitions of the BGP FSM. So that is a very Googleable term. And even though this is kind of hard to understand, I can go and Google for that and hopefully find something that is, here we go. So BGP Fundamentals, Cisco Press. So this is an educational resource that's meant for a wider audience than just other professionals. So, all right. All right. So, all right, and I wanted to look at the Wireshark Capture. Let me make sure it's still running, and then if that is the case, I'll go ahead and, and I can't really test that it's still running, so I'm just gonna make sure I've got a fresh one. Just, even though it might still be running, I'm just gonna do that double check on it. Start over new. There's a lot of old packets in there anyway. And you can see it's continuing to send out those ARPs too, because that other side is down. So there's that handshake, and you notice it's only from one side this time because the passive command is issued on router E, which is at .1. So .1's not going to send out any TCP SYN messages, at least not relating to BGP. And yep, everything went good. So once the three-way handshake is completed, the next BGP message is the open. Then we got a keep alive. Then we've got an update. And then just more keep alives and updates, depending on if you add a route, remove a route. Of course, you might have a notification if there's an error, but that's the only opens you'll get. Looks like you get one for each side. Your opens, one sourcing from .2, one sourcing from .1. So yeah, I guess it's really not that complicated. I'm kind of curious what this, something was reset. So just something with TCP or window size was reset. Or, yeah, I can do further explanation into TCP at some time doing a video, but it's not going to be on this exam. But yeah, that's it for this video and for this lab. So the next lab is going to be, oh, actually it's not. So the next video is just going to be verification of this lab. Starting here with the show BGP neighbor. We'll just see what the documentation thinks is interesting to point out. If there's anything I missed, just kind of on my own thinking about what might be important to check, that'll be in the next video. So thanks for watching and stay tuned for the next one.